Buckling analysis in X7 received a significant improvement as the analysis can now be performed for selected model parts as well, not just for the entire model. This way the software calculates the buckling modes of the selected elements of the structure only. The entire model is involved in the calculation, but elements outside the analyzed parts only act as elastic supports. In the example model, a transmission line steel tower is set up with all of its necessary load cases and loadings. Buckling analysis has its separate tab from where the eigenvalue analysis can be started with the first icon of the toolbar. By default, the software takes second-order effects into account on the entire model. Number of requested buckling shapes can be set, and after clicking OK, the software will calculate them for the combinations which were selected. The results of the buckling analysis are the buckling mode shapes and the eigenvalues. In the first drop-down menu, the 30 calculated shapes are listed. Checking the first shapes, it seems that they are local buckling shapes of trusses. They are scattered all around the structure and fills up most of the calculated mode shapes. Global buckling shapes starts to appear from the 20th calculated buckling eigenvalue relatively late in the list. Let's assume that we want to design the first assembly unit. In order to get relevant buckling results for this part of the structure, we probably should calculate hundreds of buckling shapes. However, if the buckling analysis can be focused on certain parts of the model, calculating unnecessary amount of buckling mode shapes can be avoided. To do this, we need to organize the model into model parts. Two are defined for the first assembly unit. One contains only the girders, the other contains the girders and the trusses as well. Having parts defined in the model adds further options for the buckling analysis. On the buckling analysis dialog, we can extend it for model parts options. First, here we can add each model part for the buckling analysis. Running the buckling analysis on a part will mean that the geometric stiffness matrix containing the second-order effects will only include elements within the selected model part. Second-order effects are ignored on other elements. The rest of the structure will provide elastic support for the selected part with its original stiffness. Second, we can assign load combinations and load cases for each part separately, on which the selected model part should be analyzed. Results of the buckling analysis for each model parts are organized into separate folders under the drop-down. Checking the results for the assembly unit, we will see that all 30 shapes and eigenvalues are corresponding to this model part.